Thanks all for coming back for this afternoon. I said I'd look very briefly at the Etherpad to see if anyone mentioned any specific areas of research that they're interested in. Atmospheric models is, nope, there's been no updates there. Great. So for this afternoon, we'll actually be finally able to run some jobs on ARCHER2, because I know I've been talking a lot about it, but yeah, the first part of this afternoon we'll be talking about the programming environments, talking about things like compilers, loading modules, using modules, that sort of thing, and then we'll finish by submitting jobs and how to use the Slurm job scheduler on ARCHER2, which should be quite fun. I quite like using Slurm. Is a bit sad, but there you go. With that, let's get started. So ARCHER2 uses a module system. And what does that mean? It means that the easiest way to do it is to show if you run module avail, it should, unless I'm mistaken, yeah, here we go. It will show you every single module that's available on ARCHER2. And those are the centrally installed ones that are upkept by HPE, as well as the ones that are looked after by the ARCHER2 support team. I'm gonna just go through the entire list so that we can then look through the list, like through different bits of the list. So anyone can use module avail to bring this out. And this is, yeah, as I said, it's a list of all of the modules that are currently available on ARCHER2. So for instance, you know that there's, you know, if you're using Python for anything like that, you've got access to a matplotlib module if you want to do some plotting. There's also a PyTorch module if you want to do some machine learning, a couple of other things. There are some, you know, there are libraries. I mentioned before there is a version of MKL available. There's the version of MKL. If something's got a little D next to it right here, that means that that's the default module. So you'll notice that there are two versions of MKL. There is 19.5-281 and 21.2-2883. When we get to it a bit later, if you were to load the MKL module without specifying the version, it would automatically go for this one rather than considering that one. Here we've got a lot of the scientific software that I mentioned. So things like VASP are here, CASTEP are here, LAMPS is here, and a bunch of others. And then we've got some, you know, some tools that might be useful, like GNU-plot if you want to do a quick plot, ImageMagick if you want to look at an image. And a couple of other ones. We'll be using XT-High a lot. I don't expect any of you who know what XT-High is, but it's a handy little program that was written by one of the people from HPE who works on ARCHER2. And it's a nifty little program that lets you play around with, in this case, we'll be using Slurm, and tells you how different MPI ranks or OpenMP threads are assigned and to which course they're assigned. So we'll be playing around with that a bit. And then you've got other things like the HDF5 libraries, some performance profilers, some debuggers. There'll be a debugger around here somewhere, the FFT library, lots of other things. Okay. So when you've got, so when you're logged into ARCHER2 and you don't have any first login, you can see what modules you have by typing module list. That tells you all of the modules that you have automatically loaded. So you've got here, that's telling you you've got the Cray compiling environment. When you first log into ARCHER2, you'll always automatically have the Cray compiling environment loaded. The Cray programming environment version 2.7.6. This is just more about the Cray programming environment, telling you which architecture you're using. libfabric. Libfabric is telling you what type of communication you're using. The Cray network type, we're using the OFI network type. You can also use UCX if you want. By default, there's this thing called perf-tools base. Perf-tools is performance tools, and it's a library written by HPE, which includes a lot, which encompasses a lot of the standard maths libraries. So things like LAPACK, SCALAPACK, BLAST, that sort of things. they've got their own versions of those all written there, and they're automatically preloaded, which means that it's a lot easier if you're compiling anything that uses any of those libraries. By default, they're linked to the compilers and compiler flags. We'll talk a bit more about that probably at some point in this session. And there's a couple of other ones. So for instance, mpitch, I'm skipping this one because I'm not too sure what that one is, but we'll get to that. I'm back to that in a sec as well. Oh, sorry, libsci is the one that gives you all of the performance and math libraries. perf_tools is it helps you profile your programs if you want. This here is the programming environment that you've got. So we're in the Cray programming environment, which means we're using the Cray compiler. So number 1 and number 10 go hand in hand. And then there's Bolt, EPCC setup, end, and load EPCC module are two modules that are always loaded, and they allow you to see all of the centrally installed modules that are maintained by EPCC. So if I were to remove those modules, I wouldn't be able to see, say, GNU plot, or I wouldn't be able to see, say, lamps. Okay. Now, if there's any modules at this point that you're interested in, I'll take xpmem because I said I didn't know what it was. You can always look them up by running module help. And sometimes they've got a helpful help page. In this case, it doesn't. Or you can do module show, which will tell you what it does. And here it's effectively setting a couple of environment variables, adding something to a path, and you can always at the top of the module show see the file for the module file, and if you're so inclined, this is very advanced stuff. Like, you don't ever really need to look at module files. It's more I'm being nosy. You can see exactly what the module file shows you. In this case, it really is rather informative. So maybe not the best of examples to use, but there'll be another example that's later. So module list we've done. So on a lot of HPC systems, there's a command that you can use. Before I get to that, let's go with what do I do if I want to load a module? Let's say I want to use lamps. I can run the module load command and then the name of the module. If I do that, it'll load whatever the default version of lamps is. And module available lamps will show me just the versions of lamps, and you'll see that the default one should be 29th of September 2021. I run module load lamps and then module list. You'll see, let me check. You'll see a couple of things. First of all, lamps is loaded. You'll also notice that my programming environment, which used to be Cray, is now GNU. And likewise, my compilers, which used to be the Cray compiler suite, is now the GNU compiler suite. And that's because as part of the lamps module, some other modules, the GNU compiler suite and the GNU programming environment, are preloaded when I load that. So that means that module files are actually quite useful and are quite helpful for trying to. Sorry, what's the word I'm looking for? They're quite powerful. You can have module load commands within a module file in order to load all of the prerequisites and set all of the programming environments. I doubt that lamps will be any better because I'm pretty sure I wrote the module and I didn't do any help on there. But if I try module help lamps, oh, more. Let's try module instead. Help lamps. There is some information about this, and it tells you it's lamps. The version is the 29th of September 2021 version, stable, and it tells you, it tells you this is the version of lamps. Who compiled it, which in this case is William, and apparently I modified it in November. Sure. And it tells you if you want to run it, here's the executable. You can do module more lamps, show lamps. And again, you get a bit of information. It tells you a bit about what it does. So see, as I said, it loads up the Cray programming environment 21.09, so we're even changing programming environments before we change to the GNU programming environment, make sure that we've got the correct GNU compilers, and then we prepend, we add this to the path variable. Indeed, if I do echo path, you'll notice that the first bit here matches exactly this bit. Okay, great. So I've got lamps, and let's, for the sake of arguments, pretend I didn't want lamps really, or I didn't want this version of lamps. What do? There's a command called module swap or module switch, both work. By default, it'll autocomplete to swap, but I'm pretty sure if you do that, but you can type in switch and it should still work. Lamps, and then let's swap it for the other version of lamps, which is the 13th of June version. Seems unhappy. Why is it unhappy? Why am I here? Let's go back to, here we go. List. So there's been a problem with what's been running here. So let's try a different module instead. I don't know. Let's go OpenFOAM. Module avail OpenFOAM. And let's go load up this one. Maybe it'll load up. Maybe it won't. One thing, you can do ML instead of module load, and it'll do exactly the same thing. Module list, you'll see OpenFOAM is there. And now if I want to module switch, OpenFOAM to OpenFOAM, let's do .com because I wanted the completely different build, and let's do v2106. There we go. And the other thing about ML is if you don't put anything after it, it'll assume it's a module list. So you can save some time by just writing ML. I always forget to, but you can. And there you can see after I've done the swap, I've gone from having openfoam.org version 9 to openfoam.com version 6. Great. What if I don't want OpenFOAM at all? You can module unload OpenFOAM list, and there you see number 15 OpenFOAM is gone, and likewise unload lamps module list, and you'll see actually I've got only 2 modules available. Sorry, I've got a number of modules unavailable, and actually it's purged all of my modules. And actually the reason for that is because we swapped to a newer version of the Cray environment. And because it's a non-default version, when you unload your modules, you lose access to the EPCC modules, which means you lose access to all of the module files. And if I do a module avail now, there shouldn't be that many there. Well, there are still a fair few. Yeah. So in this module avail, you'll notice that all of the centrally installed, the ones that are installed and managed by the CSE team, the ARCHER2 CSE team, are no longer here. So things like lamps, things like GROMACS, things like OpenFOAM, they're not there anymore. And actually this leads to this message here that I mentioned of that I started reading. But like, unlike many other HPC systems, because of this very reason, because you lose access to a ton of super useful modules, when you do it, running module purge. Let me try to type. Also means that you've only got access to also means that you've got access only to the Cray modules. And actually what we recommend often is that you log back out and log back in again, and you'll be back to your default module environment, which is what I'm going to do. Try to remember my password. And now if I do module list, module avail, we've got all of the central ones again. So that is loading, unloading, swapping, purging, and modules. I'll see if I've, and checking what's available. One extra thing about module avail, while I think about it, is, let's say, I don't know, let's say I'm interested in whether GROMACS exists. I can do module avail GROMACS, and it'll come up with, you know, there are 2 versions of GROMACS, that's fine. Let's say there's a for whatever reason, let's say I'm not sure how to spell Gromax, this accepts wildcards. So the module avail Grom should output the Gromax ones. Nope, it doesn't. I tell a lie. Here we go. Trying to think. I'm sure it used to, but anyways, it doesn't anymore. So it doesn't accept wildcards. What if I just do Grom? There we go. So you don't need the wildcards, but you can put parts of a word and it will output what's available for that. So if you wanted everything that starts with OP or has it, yeah. Got the open foam. I'm not sure why these are here. Open sh memhex makes sense. Why are, oh, there we go. It's because of OP in loops. So anything that contains OP anywhere gets shown here. Yeah, we've done all of that. So licensed software. I keep talking about the licensed software. I'll use VASP because VASP is, you know, one that I've used that I keep talking about. There's a ton of different versions of VASP, and if I do module help VASP, it tells me this is the VASP module. Once this module has been loaded, you can access the thingies. If you're only interested in, yeah, for access to VASP, please look at this site. And if you look at this site, oops, wrong one. It just tells you, copy the link. It just tells you, it takes you to the stage that I was telling you about before, where amongst other things, it'll say how to access. There is a, if you go down, we'll get there, I'm sure. Oh, maybe it's gone. Okay, that's been updated. So that module file needs updating. I'll make sure to let the person in charge of that module know. Cool. But going back to VASP. Go. Going back to VASP, it says, you know, you need access for it or whatever. Does that mean you can't load the module file? Well, no, it doesn't. And I'll just show you if I do module load VASP, module list, you'll see the VASP module is fully loaded. And what does that mean? Well, if we do a module show VASP, all that loading a module does is it sets up the correct programming environment, and it adds a number of, it adds certain things to certain path variables. It sets some environment variables. In this case, it adds some stuff to your LD library path environment variable. It sets the UCX ID reg methods. It adds something to your path variable, and then it sets a couple of other environment variables. So I don't know, for instance, if I'm sure you believe me, but if you didn't, you could run echo any of these, and you'll see that that matches exactly with that. It sets all of those variables, but it doesn't actually give you access to the files. And you'll notice in here it says once you've loaded it, you should have access to VASP std. If I try to do autocomplete on VASP std, I don't get anything. And likewise, let's see, there we go. Presumably all of the executables will be in the /bin directory. If I try to run ls/bin, I don't have permissions for that. And that's where the asking and requesting for package access comes into play. We keep those packages in special groups where unless you're a member of that group, you can't see into them. So that's why you need to request access to these packages, because otherwise you do not have the permissions to even see the executables. Cool. So that is licensed software and how we run it. And just to stress the point, there we go, will that be happy? Module help lamps. Lamps says you should have an executable called LMP. If I do lm, there we go. And if I do which LMP, it tells me which LMP it's looking for. So I have access to LAMPS because LAMPS is not a licensed software, but I do not have access to, like if I do which FASP std, it doesn't find it because I don't have access to those files. Cool. So we've covered a bit about module help as well. And we've covered loading and switching modules. Yeah, and we've covered ML. So hierarchical structures, I will exit and log back in for this one and remember my password, I'm sure. Yay. So let's do netcdf, because I said that netcdf was available on ARCHER2. And it is. Is it? So there's a netcdf and there's a cray netcdf here. We can find both of those, but there's an other command called module spider, which if we use, will tell us all of the dependencies for loading this. So cray netcdf, the spider command tells you that there is a version of cray netcdf. There's actually 3 of them, 4.7.4.3, 4.7.4.7, 4.8.1.1, and then there's also the netcdf HDF5 parallel and this one. But if you look back up here, those cray netcdfs didn't appear when I looked for them. There are other possible results, and it sort of tells you how you can look for other possible results. So how do we find out how to load these versions that weren't present initially in our initial output? What we can do is, let's take this one, and we can do module spider, this. And here it tells us you must have one of the following modules loaded before we're even able to let you have access to it. So you will need to load all modules on any one of the lines below before this is available to you. And indeed, if we were to try it, sorry, I mean, this is the bit of the course that William's changed since the last time I ran it, so I apologize if I am a bit less fluid with this part. If we try to load this, it'll just tell us we've not found it. There's errors. You need other stuff before you can even do it. So yeah, fine. It says that we need to load these. So what if we do a module load these? List, check they're loaded, and then let's do a module load cray netcdf. There we go. We are able to load it that way. So the spider command is excellent for letting you know what is available what versions of a specific module are available, and how to load it. And the reason why the spider command can be useful is because there are 3 programming environments on ARCHER2. I sort of briefly talked about them, but there's the cray programming environment, there's the GNU programming environment, and the AMD programming environment. And with each of these 3 programming environments, there's also a what do you call it? There are different compilers, there are different modules that will only work under certain ones of these programming environments. And the system that we use to handle modules, the LMOD system, will only ever show you the modules that are available based on what you currently have loaded. And if something isn't available based on what you currently have loaded, it won't show it to you when you do module avail. So module spider lets you see, basically it lets you tell LMOD, I don't care what I have loaded, tell me everything you've got that has this name. And the other one that you can do as well is, okay, now that I know exactly what you have, tell me what I need to load if I want this specific module. And that's why I'm talking about this, and that's why William included these in the notes. But I hope that makes sense, at least the reason behind it. So if I guess the important thing is if you can't see one of the modules that you think should be there when you use module avail, try looking for it with Spider, because it might come up, and then you'll be able to know exactly how to get access to it. So switching between programming environments, I've mentioned that there's 3 programming environments, and exit and log back in. I've mentioned that there's 3 programming environments, and we always start off whenever we first log in with the Cray programming environment. Well, that's all good and great, but what if I wanted to compile with let's say the GNU compilers? How would I do that? The way to do that is you can do module load PRGENV for programming environment. And then if I do an autocomplete, you've got the AOCCs if you want the AMD programming environment, the Cray if you want a Cray programming environment, and GNU if you want the GNU programming environment. So let's go with GNU. And it'll tell you, okay, LMOD will automatically start by replacing the compilers you're using from being the Cray compilers to the GNU compilers, and will also automatically replace the programming environment from Cray to GNU. And we've also had to, because you've changed programming environment, we've had to reload the mpitch library. Now if I do module list, you'll see that we're in the GNU programming environment, and you'll see that we're using the GNU compiler suite. And I could do this for maybe if I push load, that helps. Load AOCC. It does exactly the same thing. And now we're using AOCC and the AOCC compilers. Cool. I'm trying to think, would that work? Yeah, it does. So because this is a Cray system, rather than using, because this is a Cray system, Cray provides these things called compiler wrappers, which wrap together not just the compilers, but also a lot of the Cray libraries, like the ones in the Cray libsci library that I talked about before, into these compiler wrappers. And the compiler wrappers are CC for anything that's C, for C. You've got CC for anything that is C++, and you've got FTN for anything that's Fortran. Yep, and it's not going to be happy because I'm actually doing commands there. Maybe I should. Yeah. So what you can do is to check that you're using the right compilers. You can do CC -- version, and that tells you at the moment the C compilers are Clang version of so Clang version 10.0.0. And so I know that I'm using the Clang version of the MPI enable C compilers. And likewise, if I were to do MPN, it tells me that again it's the Clang version for that one. And if I changed to the GNU programming environment, I've seen that there's a question. I'll get to it in a sec. It looks like Eleanor might have gotten there first. Yeah, and now if I do FTN version, it now says GNU compilers. Yeah. So yeah, that's a quick overview of the compiler wrappers and switching between programming environments. I'll just quickly look up at the questions. So one of the questions is, are Intel compilers available on ARCHER2? They are not available on ARCHER2. There's the Cray compilers, which are based on Clang, there's the GNU compilers, and there's the AMD AOCC compilers, but not Intel. Cool. That's everything for programming environments. Now, one of the things is, I mentioned this for lamps actually, so unfortunately I've been getting a bit ahead of myself with a few things. But there you go. You might want to use a different programming environment entirely. And the thing with that, like, why might you want to do that? The current programming environment has a current version of the compilers, and maybe you want a newer version of the compilers. Maybe they've also been, like, as the programming environments get better, the lempitch libraries get better, so you might be able to get some optimization, performance optimization by changing programming environments. So how can you do that? There's actually a couple of steps, and all of the steps are in the lamps. Module, so that was a bit unfortunate that I chose that one. But the steps are, you want to change to the newer version of the programming environment. So module list, is there a CPE in there somewhere? There is not, but I think the default, Eleanor will correct me, but I think it's, are we on 21.7? I can't remember. Oh, it'll say in the docs one. Environment, does it say which version? Not, and if I say changing programming. Changing programming environments is a whole section. 2104 says Eleanor. I'm tempted to trust Eleanor. Where am I? Changing programming environments. That's not the right one, is it? Cool. And Eleanor says that the default is 2104, but that we've also got 2109 and 22. I think that was 04. 2204, yeah. Cool. So, anyways, going back to module show lamps. Yeah, if you want to go from the current 2104 version to, let's say, the 2204, you can basically just follow exactly what it says in the lamps one. So you do a module load CPE 22.04. There we go, which tells you, oh, we've had to reload a ton of things. And module load programming GNU. Was I in GNU? I wasn't. Then module load. You don't necessarily need to, actually you don't need the last one, because if you do a module list, you'll see we've already got GCC there, and you'll see we've also got a new programming environment. This will definitely not change anything in the version. It tells you it's 11.2. However, regardless of the version of programming environments you're in, switching the compilers will always switch the version. So let's say we want, I don't know, let's go back to 8.1. I don't know why we want to do that, but there you go. If you do ftn --version, the version is now 8.1, whereas when we were on 11.2, it was 11.2. So yeah, if you want to change the version of GCC, we've talked about that. We've talked about the different version of the libraries. Oh, that's a very important point, actually, and one that you don't see just by doing module help. Module show lamps. Nope. Which is that if you look at the actual module, if you look at the actual module file, you will see that the. Do you see that? No, you don't. Oh, interesting. One of the things you need to do at the end, if you've updated or changed any of the compilers or anything like that, you need to use this export command to update your LD library path to include the new Cray LD library path. Unfortunately, this is a known issue with ARCHER2, which is that when you change the version of your programming environment, there are some variables that should be automatically updated, which no longer are. And so you need to do it manually. So in this case, if we did want to, for whatever reason, run in version 22.04 of the programming environment and wanted to use the really old 8.2 compilers, we would need to export this. Otherwise, certain paths would not be updated and our executable would not be what we expect it to be. Okay. Before we go on to compiler wrappers, there's a quick thing I wanted to show actually. Where is it? I can remember passwords. Because I've said that module files can be really powerful, and they can, but that's completely useless unless you're able to do like keep your own or manage your own, right? And so what I'm going to do is I'll just keep using, I'll use GROMACS actually. Not sure. I don't want to load that. I want to show GROMACS. There we go. I'm just going to copy. Ooh, what happened there? Copy that file, which is just the module file. I'm just going to copy it to here. And now instead of module load GROMACS, I'm instead going to do module load the path into my work directory. If I can get there. There we go. 2021. Oh no, it won't find it because fine. This. And has it detected error? Oh, is it because I don't need a Lua? Nope. Okay, that might be for a previous version of. There was a point where you could have you could set module files and you can add paths to the paths in which LMOD will look in order to have, for instance, a shared module file that anyone within a group can use. In this case, it is unhappy with. It just doesn't know about them. So because it's not part of the paths, it doesn't know about them. If you do module show EPCC setup end, that'll show you, amongst other things, how you can set up, or you can Google it actually. LMOD has got a ton of information about it, but you can set a new module path and you can add new folders into a module path, which means that you could, for instance, and I have seen groups do something along the lines of, in the shared directory, have a groups modules that everyone within the group can have access to, and as long as they load the, put the correct prefix into there, which I think would just be this, like export module path goes to there, then everyone within that group is able to load the module files in there and get access to maybe some executables that your group uses a lot and is shared amongst people within your group. Yeah, the demonstration was terrible. I'm sorry about that. Does that all make sense so far? And do you have any questions or anything you wanted to ask or dig deeper about regarding modules and LMOD? Cool. Actually, I don't need that. Cool. So with that, let's carry on. Oh, cool. So I've talked a bit about compiler wrappers, and basically compiler wrappers they're there to ensure that all of the correct libraries, all of the correct header files are included whenever you compile and whenever you link. So what's a linked library? When you load a module, you'll automatically set all of the necessary paths and link flags for that software. So things like LD flags or anything like that will automatically be updated. So when, for instance, if you use the cray libsci module, which is always loaded by default, and it sets the wrappers to link to the BLAST/LPACK and SCALAPACK functionalities automatically. So you can have access to BLAST/LPACK and SCALAPACK automatically because it's included in the compiler wrappers without having to specify the -library libsci command. So there are 3 compiler wrappers. There's FTN for Fortran, there's CC for the C compilers, and there's C++, there's uppercase CC for the C++ compilers. And as I've shown, there's a lot of things that get updated whenever you change programming environment. So if I do CC version, we're in play clang 1104, module load, programming environment, scope new. If I do CC version now, it's GCC 10.02, and if I do AOCC and do version, it's AMD clang rather than the previous. The very first one was, where is the very first one? Cray clang. Sorry. Cray clang 1104 at the start, and at the end we end on AMD clang 10. So it updates that, but it also updates all of the libraries as well. So like it will link to the correct cray libsci library, which means that you've always got the correct type of maths libraries and all that sort of thing. If you were to load an FFT, if you were to load the FFT module, then you'd always have the correct FFT module, all that sort of thing. And actually, the thing I wanted to do is I'm going to very quickly off screen look for quick empty like hello. Where am I? I should have prepared this before, I'm sorry. Where is it? Actually, I might have one. Otherwise, I'll just Google for. Cool. Sorry, this is taking a bit longer than I thought it would. Sure, it was in here, not there. There it is. I'll go for C because why not? Cool. I'm gonna remove that directory and remove that because that really didn't work. And if we do hello.c. So this is just a parallel. Oops, didn't mean to click off that. This is just a parallel hello world for C. I can use the compiler wrapper to compile that, and you'll see it's created my executable a.out. And now, and this is quite important actually, because it leads quite nicely to the next thing we're going to do. You'll notice this is executable, and anyone can execute it. If I try to run it, it'll run on a single processor. So you can see that it's compiled a parallel hello world in C, and it's able to run on a single processor. Now, if I wanted to run it on more than one processor, I'd need to use, I'm pretty sure there's no MPI. There's no MPI run, so I'd need to use srun, and as soon as I use srun, we're getting into the point where we need to start considering, well, we need to run on the compute nodes rather than the login nodes. And actually, this is a really important point to say that if you want to run anything that has more than a single MPI rank, or anything MPI actually, you won't be able to do that on the login nodes. It will have to be on the compute nodes. So that was compiler wrappers. I'm going through this quite quickly. Please do let me know if you have any questions or if you're happy with this. I know I did this one in C because it's the first one I found, but it's exactly the same idea. Let's see. If hello parallel had been a Fortran file, then instead of doing CC to use the C compiler wrappers, I would have used FTN for the Fortran compiler wrappers. I hope that kind of makes sense. I'm sure it does. Yeah, there's a question.
Hi, yeah, I'm sort of following you. I don't really have a computational science background. I was just sort of a general question in terms of the transition of software from Archer to ARCHER2. Is that a simple process of swapping compilers, or is this a bit more of an in-depth thing?
So swapping compilers, you used to be able to do that on Archer. The big difference between Archer and ARCHER2 is that on Archer there were Intel compilers, which you don't have on ARCHER2. So if the program that you're running was using either the Cray compiler suite or the GNU compiler suite, it'll probably go fine on ARCHER2. And if it used the Intel compilers, it will hopefully go fine on ARCHER2, but sometimes it does, sometimes it doesn't. I can't comment. It sort of depends on the code in that case.
Great. I think it was using Cray compilers, so that's very comforting. Thank you.
Yeah, no worries. Like quite often, unless there are a ton of debuggers or a ton of flags or things like that within during the compilation steps, any of the compilers should be able to compile. So I mean, you know, this is the simplest of simple codes, but if I do module load, I don't know, I have no idea which one I'm on. I'm definitely not on AOCC because I never used, I probably was on AOCC, wasn't I? Let's go new, and then run CC. There we go. It still compiles. And if I do module, what am I swapping? Load, programming environment, Cray, it'll still compile. So if your program is simple and you're not using too many compiler flags, it'll compile regardless of the programming environment you use. And actually, one of the things that we do as part of the CSE team is we play around with the different compilers, play around with the different flags, play around with the different maths libraries to try to get really optimized versions of all of the centrally installed codes. One cool thing, because we're running a bit ahead of schedule. So actually, I'll ask very quickly. We're running a bit ahead of schedule. I can either talk about one fun aspect of ARCHER2 that's unrelated to the course, or we can carry on because I'm also aware that it's Friday, and I'm sure if we finish, you know, 10 or 20 minutes early on a Friday, I'm sure no one will complain too much. So could you put your hands up if you'd rather we persevere and maybe finish a bit early? Cool. So I'm seeing 3 people, and I'm going to lower your hands. 4 people is what I'm seeing. And just to check, can I ask, could you put your hands up if you want to see the slightly off the course thing? There's 1 person. Cool. In which case, we can do it because it's very short. There's a nifty command called LDD. It's just LDD and how library linking works. Actually, the dynamic linking is probably what we're going to talk about anyway, so it's probably entirely on the course. there's dynamic linking on ARCHER2, which means if we take our executable a.out, here it tells us the list of all the libraries it's using, and it tells us where they're from. So because we've compiled with the last compiler I used was the Cray compiler environment, you'll notice that things like libmodule modules point to CCE 1104, which is the Cray compiler's 1104. You've got things like libmpi here is pointing to, I mean, it's pointing to the same one because that doesn't matter. But here, like libquadmath, libmodule, libfi, all of those are pointing to the Cray compilers. If I do a module swap to programming environment, let's not go Cray, why am I swapping? Load to programming environment GNU instead, and I run the same LDD, which sort of tells you where all of the libraries are linked to, libquadmath, instead of going to CCE, to the Cray compiler's 11.4, it points to the GNU compilers. So you're able to change the libraries that are linked to your executable dynamically by just changing the programming environment, which is a really nifty trick, which also emphasizes further the fact and the point that I was making a second ago of provided you're not doing anything weird with your compilation, or you've not got like loads of flags that don't mean anything in one compiler but do in another, you will be able to, like it shouldn't matter which compiler you use. And the wrappers on ARCHER2 are, for lack of a better word, smart enough to, because there's dynamic linking, there's only dynamic linking enabled, they'll always get updated to whatever the current path is based on your programming environment. Cool. So if you need any help with any of the software, you can find all of that in the ARCHER2 documentations. And as I said before, for most of the research software, you can click on there. There's a ton. I keep going for lamps, but just to show you, Nemo is quite a complicated one actually. We try to help, and different pages. Lamps is a very simple code to run, so there's not very much in it. Nemo is a bit more complicated, and there's lots of things you can do with it. So for that, there's going to be a few more pages. There's also going to be a few more examples to help you, if you want to run in this particular case, if you want to run in that particular case. We really do try to make the docs useful. So as a first port of call, if you're unsure about something, the documentations are always a good one. And if you're still unsure about anything, please do ask us at the ARCHER2 service desk. We're here to answer this sort of question. So the key points from this session were to talk about the development environment, to talk about the compilers, and to talk about the compiler wrappers, and also a bit about the software development and things like that. Are there any questions about this part? And do tell me, by the way, please do tell me if I'm going too quickly or too slowly. I can either speed up or slow down. I maybe can't do both, so please don't tell me both. Cool. So I'm pretty sure that this was, I'll just check the schedule. So this session is meant to finish in about 20 minutes. What I suggest is, how about we start talking about Slurm for 20 minutes and then take a break at 1/4 past, as is said in the scheduler, and then we'll finish Slurm a bit earlier than advertised. Does that work with anyone? Or put another way, if that doesn't work with you, please let me know.
Yes, that's fine, Julien.
Okay. Brilliant. So I've been talking a lot about ARCHER2, but we've not run anything on it yet. So let's talk a bit about how to run something. Right. So we've got our executable, and at the moment we've got no way of, well, I mean, we do have a way, but we're not running it on the login node. So where are we going to run it? Here, I don't know. I'll run it out. There we go. So we've got our executable, and we want to run it and we want to run it on more than one core, because what's the point of getting access to a high-performance supercomputer if you're not going to be able to run on more than one single processor or one core? So to do this, my recommended method, the easiest way for me, is we're going to write a Slurm submission script. I tend to call mine sub.slurm, sub for submission and Slurm because that's the name of the queuing system. At the top of it, you will need to use a shebang to define the environment you want it to use. I tend to go for bash. Then you'll need to define a couple of variables. Let me see. All of them are Slurm sbatch variables, so they'll all start with an asterisk sbatch. And there are things like, let's see, what would we want to define? You'll want to define the account you're using, i.e. the budget cookie you're using. We're using TA081. You'll want to define the partition you're using, which in this case is standard. I'll talk a bit more about that in a sec. You'll want to define the quality of service you want to use, which in this case is going to be the short queue. Quality of service is kind of the queue. There are a couple of queues on ARCHER2. There's a standard one which can run up to 24 hours, and you can ask for, I can't remember how many nodes, but we'll talk about it later. There's a short queue which lets you run jobs of up to 8 nodes for up to 20 minutes. There is the long queue for any job that's between 24 and 48 hours long. 48 hours is the maximum amount of time that you can run a job. There's the low priority queue that lets you run a job free of charge, so it doesn't get charged to accounting. I think it's free of charge. I'll need to check that actually. But it lets you run a job, but you will only run jobs when no one else on the system wants to. And there's a couple of other ones. I think reservation is one of them for if you have reserved some ARCHER2 time, but we'll talk about that probably after the break. So, okay, I've defined exactly the type of job I want to run. I want to run on the standard partition. I want to run a short job. It's going to run for 0 hours. It's probably going to take less than 5 minutes, with 5 minutes and 0 seconds. What else? It is going to then you can start sort of like fiddling around with like defining your nodes. So I'm going to use one node. Equals 1. You could have more nodes if you wanted. Each node is going to have 128 MPI ranks, MPI tasks. CPUs per task. Each, sorry, I think it is. I'll just cheat real quick, but I'm pretty sure that's correct. Small moment of doubt. Yes, it was right. Cool. Each node is going to have, each of those tasks is going to have a single OpenMP thread or a maximum of a single OpenMP thread associated with it. And then you can start running. So when you want to run your job, instead of using something like MPI run, which is probably, or MPI exec, which is probably what you use on your laptop and on a few other systems, to launch a parallel application, you use the srun command, which is the slurm run command. And then you just name your application. In this case, it is just a.out. And once you've done that, you can submit your job by using sbatch sub.slurm. It's happy. It tells you we've submitted a job. It's got this job number. And you can do things like looking at how it's performing. For instance, it's running and it's been running for about 10 seconds. Still running. Shouldn't be running that long. And if you look, the job, rather than printing anything to screen or anything like that, Slurm will create a Slurm job number, which is exactly the same job ID as I got earlier when I launched my job, it said submitted a job with this job ID. That ID is the same as this file, and anything that would be output to screen is instead output directly into this file. And so if I look into that Slurm file, you'll notice that it has hello world from processor, the processor number out of this many processors. And so, yeah, if you've compiled your job, this is how you run it. And actually, we'll be running a fair few jobs, not with this particular executable, with another one, which does a very similar thing. It's written better. But yeah, that's how you run it. And now I'm going to talk a bit more about Slurm in general, about how to track jobs, about the different, basically about all of these variables that I named. So the first thing I want to say is there are multiple ways of submitting a job to Slurm, and we'll be talking about all of them. I really like the Slurm SBatch method, where you write a submission script like this, and then you send it to Slurm to schedule and to run with it for a number of reasons. But one of the big ones is reproducibility. If anything goes wrong with my simulation, I can rerun it exactly by running exactly the same SBatch script. And so that makes it really easy and really helpful for debugging. The other reason as well is that the other methods we'll be looking at are a lot more interactive, which can be helpful. But that does mean that if you're in a queue waiting for the nodes to free up, you might be sitting idly waiting for something to happen for a while. Whereas with the SBatch method, where is it? The job's launched, the job's in the queue, I can keep doing stuff. See, it's not even running yet. I can do that. It'll probably tell me that I've got 2 jobs running, which it really shouldn't. Yeah. But I can do other things. I can even prepare another job, all of those things. That's why I tend to go for this method. But anyways, enough about running jobs. Let's talk a bit more about the actual Slurm side of Slurm. One of the first commands you'll be looking at is probably the sinfo command. Sinfo tells you information about all of the system. As I said before, the system has 5,800 plus nodes, so there's a lot of information there. Let's break it down a bit. Got a bit bigger. So what we have here is it tells you information about all of the various nodes and all of their various states. Here, where it says partition, sinfo allows you to I guess, break up all of the nodes into their different partition types. Most of them, you'll notice, have standard. Some of them have high mem for high memory. Some of them have serial. They are for the serial or data visualization or post-processing nodes. We use many words for them. Next, it says availability. Are you able, or is someone able to launch to these nodes? For all of them that are available, that are showing here, they're all available, so they've all have up. Next, it tells you the time limit. What's the maximum amount of time you can run? It says 1-0000000. So before I said, I'm going to run for 0 hours, this many minutes, this many seconds. If you wanted to run for days, you would put 1 dash at the for start. So if you wanted to run for 2 days, it would be 2-0000000. Here, all of the, at least in these in the basic partitions, the standard partition for all of these, the maximum runtime, the maximum wall time is 1 day. Next, here it tells you the number of nodes in each of these bits, and we're about to get to why these nodes and how these nodes are divided. But here you'll notice in this first one, there's 58 nodes. In this one here, there's 567. Here, there's 5,669. And then finally, we get to the state. And the state tells you, what is that node doing right now? Drain means that it's been taken offline by the systems team. Reserve means that it's either being used, but it means that it's being used or is saved up for a reservation for someone to use up. There's another drain without a star. Alloc means that it is currently allocated and currently doing work, which means that That's quite impressive, by the way. For a system that's got 5,800 compute nodes, there's 5,669 that are currently doing work right now, or did when I output the command. There are 42 nodes that are currently sitting idle. I don't know how long that'll be. There's a couple more drains. These are for the high memory nodes, so they're a different partition, but there's 567 high memory nodes that are allocated. Part of the reason that number is so high, part of the reason that this many of the high memory nodes are currently in use, is because we have set up something so that if the high memory nodes are not being used in the high memory node part of ARCHER2, they can be used instead in the standard queue. And what that means basically is, sometimes you might just have a node that's got a bit more memory, but you'll not notice. And the memory is still capped on them. It just means that the total number of normal nodes looks a bit bigger. And then likewise, there's a couple of serial ones. One of them is in comp and one of them not doing anything. If I rerun the same command, the output will have changed a bit. So there's actually a couple more nodes that are used, a couple less nodes that are idle. It'll change very regularly. And actually, I'll take a quick moment to show this because this is quite fun. .ac.uk, ARCHER2.ac.uk, website. Probably missing a HTTPS. There we go. If you go on the ARCHER2 web page, not the documentations, but the actual web page, and you go on service status, we output a graph showing over the last, is it 24 hours? I think it's 24 hours, what percentage of the system, or how much of the system is being used, how much of the system is idle, and things like that. And as you can see, ARCHER2 is quite nicely used, which we're really happy about, because it means that people are doing really interesting science and research. The other nice thing about this page is if there's ever anything that's going wrong with ARCHER2, we put alerts there. So if you wake up one day, you launch a job, it's not doing what you think it should, check this page, because if we're aware of it, we'll have put it up there. And if we haven't, send in a query and we'll look at it. We also keep track of like the last few ones that have happened. Sorry, I diverge. That's the wrong page. Is that the wrong page? Definitely the wrong page. That's the right page. Cool. And we're okay for time. So sinfo lets you find out about the resources, and actually you can do a lot of what's the way to phrase this? There's a lot of information that you can get out of this. So if you just type sinfo, you get the top level information, but you can really get down to the real nitty gritty, and this is one of the scariest ones, which will tell you individually, node by node, what every single node is doing, I think. Yeah, there you go. So did you want to, I'm sure you'd be really happy to hear that node 6662 is a standard node which is currently allocated, and yeah, it tells you all of the information about the node. And you can do loads of various different things to get more or less information from this. As always, you can always pipe into less to kind of like help you visualize the information. That's always true. Oops. That's not what I want to do. Less minus s lets you also, because, well, one of the things about this is it's sort of hard to tell. This is such a long line that it's really hard to read. But if you do sinfo less minus s, it's a lot more easy to read, and then you can use the arrows to look a bit more, to make it more easy to visualize. And there you can see the partitions, whether they're available, the time limits, how many nodes are in each, what the state is. And the final thing I didn't say is the node ID. So you can see every single node, like for instance, I don't know. Let's say we know that nodes 1257 and all the nodes between 1326 and 1327 are all in a reservation right now, that sort of thing. If I'm being entirely honest, you probably will hardly ever use sinfo. But it's one of the nice ones that you can use at the start to learn about this. So actually, this is an excellent point to stop, because the next bit is an exercise, which I'm more than happy for you to do over the break and in the first 5 minutes following the break. But the exercise is, we've been talking about all of these nodes, we've been talking about all of this information. What happens if you run this command? It should display all of the resources that are available, the resources available for any given standard node. Is it also possible to do the same thing by node state or anything like that? And can you run, can you come up with an sinfo command that will find all of the free nodes within the system? I strongly recommend sinfo -- help, because I always use that. But there are ways of doing this command. So that's an exercise. You've got 2 minutes before the break. By all means, have a play around with this exercise, and I'll go over the answers after the break. If anyone has any questions or anything they want to talk about at this stage, please do let me know. Okay, great. Thank you to everyone for answering the poll. I'm just going to pause it. Oh, stop it, and turn on my camera. And yeah, so did anyone find any solution to this exercise? Actually, I'm kind of interested in what this brings up. Cool, it tells you the host name, how many CPUs it has, and how much memory it has. But yeah, does anyone want to put a suggestion in the chat for how to do the exercise of finding how many idle nodes there are at any given time? If I remember correctly, where is it? So sinfo minus n minus l tells you whether a node is allocated, and it tells you whether it's idle. So I would have done something like this, which just outputs all of the idle nodes. But I think that the way that the exercise expects you to answer it is there is a state flag, and I can't remember if you need quotes for this. No, with quotes works. Without quotes works. There's also got reserved and idle, so I guess that's a lot better. If you're interested in every single node which is idle, you can get both the ones that are idled and in a reservation, as opposed to with grep you only get the ones that are idle. So that's one way to do it. There are, it's a computing program in Bash, so there's going to be a problem in Bash, so there's going to be like dozens of solutions. One thing I briefly wanted to talk about is when you output this command, which outputs the host name, the number of CPUs, and the memory. Let's not worry too much about the memory, but let's talk about the CPUs, because earlier today I said that every ARCHER2 node has 128 cores. So I said 2 processors and 128 cores. Now, why does it come up with 256 CPUs? It's one of those quirks of Slurm, which is that Slurm will will name every core a CPU. That's what it does traditionally. It's a shame. It does cause confusions, but there you go. And the other thing as well is when it gives the number of CPUs, it always gives the maximum number of CPUs, including if you have multi-threading enabled. And because ARCHER2 processors do have the option to enable multi-threading, meaning that you can run 2 threads per core, then what Slurm does is it counts the total maximum number of possible threads, which is 2 threads per core. There's 64 cores per processors, and there's 4 processors, so 64 times 2 times 2. is 256, and that's where Slurm gets that number from. It's very misleading, I find, and it's unfortunate that it does that, but just thought I'd explain the reason behind that. So let's just check. I'm pretty sure. Yep, and you didn't need the quotation marks. And I've mentioned this before, but if you've ever got any questions about any of the commands, but especially the Slurm commands, running any Slurm command with the health flag will give you a lot of information about what you can do with them. And if you look at the manual page, again, man is for manual. If you look at the manual page for any of those, it'll give you a very in-depth detail of all of the possible options that you can have, but also a lot of information about like what every setting can be, how every setting can be used, and goes into a lot of depth. If you're into, if you really want to know how to squeeze every single bit that you can out of Slurm, the manual page can be useful. But frankly, quite often, you don't need to worry too much about that. Just the help command will work fine. Cool. So next, we're going to talk about running batch submission scripts. And at this point, if you do have an ARCHER2 account, I hope you've been sort of like following along doing the exercises as well while I've been doing them, because it's a lot more fun. But we're going to be using this lovely little program called XT-High. And XT-High, what it does is it will take all of the settings that you've defined here. So, if you've defined a number of nodes, it'll take that into account. If you've defined the number of tasks per node, it'll take that into account. The CPUs per task, it'll take that into account, and it'll tell you what every single core in your that you've used is doing. Is it currently a thread within a rank on a node, or is it a rank on a node, or that sort of thing? So it's really nifty. It's a great way. It's a great tool for if you're interested in controlling the position of various parts of your job against the actual physical processor and the cores on the actual physical processor. It's a great way of doing some test runs. So all I'm going to do is I'm going to take this, and by all means, if you want to do this at the same time, please do copy paste, play around with this. Again, set.slurm because that's what I'm used to. And so very quickly, what am I doing here? I've gone through this a bit before, but bears repeating. At the very top, you've got you're naming the shell you want to use. I want to use bash. This command here, -- job name, lets you define your job name. In this case, my MPI job. I want to run this on 2 nodes. I want 128. I want 128 MPI tasks per node. I want 1 OpenMP thread per task. I'm going to run this for a maximum of 10 minutes. It'll take under a minute. The partition I want is the standard one. The QoS I want is the standard one. The account I want is TA081. You will want to change that if you're running this. And then the following, the hint no multi-thread and the distribution block. Let's start with hint no multi-thread. As the name suggests, I've already mentioned that there is multi-threading available on ARCHER2. Hint no multi-thread says, I do not want multi-threading enabled. And part of the reason for that is that there are a number of applications which are hindered and go more slowly with multi-threading than without. Multi-threading is a lovely idea, but we find that for a large number of applications, it does not lead to speed up. So disabling it means that you're using the actual physical core as opposed to 2 virtual cores per physical core. And we find that very often you get a performance improvement. This is not always the case, so do always test. And we strongly recommend that you always test. Run small, quick jobs to test that everything you expect will happen is happening. Now, the distribution one lets you define how you want the jobs, the cores, to be assigned. The first one tells you how you want it to be assigned between the different nodes, and the second one tells you how you want it to be assigned within any given node. And distribution block, the first block means I want you to assign all of the tasks that I'm going to give you in a way that you fill up a node entirely before you start moving on to another node. That's the first of the blocks. Now, the second of the blocks is to do with the, well, it's to do with the processor, or it's meant to be to do with the processor, but I think that we've said it here that it's to do with the NUMA region instead. And what it does here is it'll say, fill up a NUMA region entirely before you move on to another NUMA region. And so what'll happen is, hopefully, Slurm will take our job and we'll try to run it on all of the 128 cores per node times 2 nodes, so 256 cores that we have available. And the first task, it'll assign to the first processor, processor 0, for the first processor, processor 0, on the first node, node 0, on the first core of that processor. Sorry, there's a question very briefly in the chat. Will the recordings be made available? The recordings will be uploaded onto YouTube. And if you go on the ARCHER2 webpage, I'll show this real quick. If you go on the ARCHER2 webpage, you can see under training, there is a course repository. Once this course is run, it'll go on the course repository. And if you click on this course, this is a previous course that's been run. We embed the videos into that page. So you should be able to find them on this exact same page as you were on to get to the course material. Sorry. So going back to distribution, yeah, the block means the first task will go on the first core in the first processor on the first node, which is core 0 on processor 0 on node 0. Yeah. And then the second one will go on the second core on the first node, and the third one will go on the etc. And it'll fill up a node before it does the other one. And then the second of the blocks says, and oh, and by the way, fill up a NUMA region before you move on to any other NUMA regions. The other one that you might be interested in using, and we'll be playing around with it later, I suspect, is there's a cyclic command. And what cyclic means is instead of filling something up, you want to spread it out as evenly as possible. So the first one will still go on core 0 on processor 0 on on core 0 in NUMA region 0 on processor 0 on node 0. But the second one will go on core 16, which is in NUMA region 1, which is still on processor 0, which is still on node 0. And so you're kind of like distributing your job as evenly as you can amongst all of the resources that you have. Before the colon means that you're distributing amongst nodes. After the colon means that you're distributing amongst NUMA regions within a node. That's a lot to take in, and you'll see a lot more visual representation of what I've just said. But at this point, are there any questions about what I've said, or did that all kind of make sense? Stunned silence is worrying. Makes sense. Excellent. So all of these here, because they've got the sbatch commands, you can tell. Well, the sbatch commands tells you that they're Slurm commands. They're telling Slurm what you're after. And after that, you can start writing your script, and your script is exactly like any other shell script. So what are we doing? Well, we're loading a module. The module is xt high. We're exporting the number of OMP threads. We want OMP num threads to be 1. And then we're just going to srun to run a parallel version of xt high. So with me having spoken a lot, let's see what happens when we do that. What did I just type? I'm typing the watch command, which lets me follow whatever the following command is. And the following command is sq, which we'll get to in a sec. And --me is, actually, I'll get into the sq command now because that makes more sense. Sorry about that. So sq is a command that will show you every single job that is queuing at the moment. There are a lot of them. Every single job has a job ID, It tells you the partition it's being run on. It's got their job names. It's got the username of the user who's running them. Here it tells you the current state of the job. Here it tells you how long they've been running for, how many nodes are they using, which nodes are they. So this node, for instance, for this one, for instance, has been running for 4.5 hours on 40 nodes, and these are the nodes, and it's called Nemo test, which suggests that it's a Nemo test. If you go up, there are a fair few jobs. But eventually you'll reach these jobs, which are in state PD. So instead of R for run, they're in PD for pending. What that means is they're in the queue. And there's a couple of reasons they might be in the queue. This one here is job held user, means that the user has asked for this job not to run. There's ways you can do that. Priority means it's pending until some of the nodes come up and it has a high enough priority to be the next job to run. Dependency never satisfied. I suspect that means that they've requested something which is not possible to ask for. Likewise for dependency. And if we keep going up here, ASOC max CPU minutes per job limit. That tells you that this person does not have currently enough budget in their account to run this job. And so the job is held until they increase their budget. It's not the most helpful of error, but if you ever get an ASOC max CPU minutes, that means you're probably out of budget. So have a look in safe to check. And most of these are priority. Max jobs per user limit is exactly what it says. This user has submitted too many jobs to this specific QoS, to the specific queue effectively. And so this one is not allowed to run until all of the other ones have finished or exited. And that's pretty much most of them. Dependency never satisfied just means it's impossible to run the job. Usually that's when people have requested specific nodes. Yeah. And clear that. And by this point, my job will have finished. But let's remove this learn file and let's run it again. Oh, that's not going to work. Sub.learn. And now I'm going to run watch SQ. And by doing --me, I am asking SQ to only show the outputs that are relevant to me. Is dependency when you ask for low priority? That's an excellent question. I don't know the answer to that, I'm afraid, but I'll look it up. What was the command? So the command I ran is watch. Watch is a command that lets you it will output whatever command you put after it every 2 seconds. So I can do a watch ls, and every 2 seconds it'll output all of the files in this directory. You'll see here at the top, it's updating maybe 3 seconds, but close enough. There's not much happening. So that's the watch command. Now, the other command I did was sq minus me. The sq command shows you the entire queue. Minus me shows you just your bit of the queue. I've got nothing running because my job is finished. But if I remove that again, submit that, and run sq minus me, you see that it outputs, instead of outputting the entire queue, it outputs just my job, which is called my MPI job. It's a bit too long to fit. It's been submitted by me. It's currently running, and at that point I output it, it was running for 2 seconds. If I look at it again, it's already finished because it's a very quick job. My job is output, and if I look at it, all it does is it's very similar to the hello world that I was doing before, except everything is in order, and it tells you exactly how the tasks were divided. So the first task went on node 0, it had rank 0 and thread 0, and its affinity, i.e. the actual physical core with which it is on which it is set, is 0. So it's on the 0th core of the 0th processor of the 0th processor of the 0th node in the ones that I asked. This one's a rather boring job insofar as you'll just see things going up until the point where we get to 128. There it is. Where instead of being on node 0, it swaps to being on node 1. Yeah. I'm going to move this to block for that. And let's see whether I was right about the cyclic one. As you can see, it's running, it's running. I'm hoping to get it when it's just cancelling. Should be soon. There we go. When your job runs, it'll go from PD, which is pending, to R, which is running, to CG. And CG means cancelling. It means that your job is in the process of exiting. And that's kind of why I've been running a bunch of SQs in order to show you this. Once it's finished CG, your job is no longer in the queue. And here, so let me explain a bit more. Sorry, I'm being terrible at explaining today. The only thing I've changed from the previous job is instead of doing a distribution block, I've changed it to block cyclic. And what this will do is it will set each of the tasks. The first task will go on node 0, but in NUMA region 0. The second task will go on node 0, but in NUMA region 1. And the next one will be node 0, NUMA region 2. And it'll sort of like spread the tasks. The first 8 tasks will go in one in each of the NUMA regions. The next 8 tasks will go in in each of the 8 NUMA regions. And it'll do that and do that and do that and do that over and over again until node 0 is full. And the reason it'll do that until node 0 is full is because I still have a block here. And if we look at the output, we see that the first task is on node 0, it's got rank 0, thread 0, and its affinity, the core that it's actually tied to, is core number 0. But the second task is on core number 16 as opposed to core number 1. Then it goes to 32, 48, 64, 80, 96, 112. And then it wraps back around still on node 0 and starts filling up core 1, 17, 17, etc., etc. And only once core 0 is full, once we get to task 128, will it start doing exactly the same thing, but on node 1. Sorry, I'm realizing that I'm taking a bit of a time talking about this, but I think that there was someone in the morning who asked a question related to this, so I just wanted to emphasize this is probably the easiest way to distribute or not across NUMA regions by just using Slurm functionalities. Yeah. So let's have a look. So we've done all of that. Reservations. So I've not really talked too much about reservations, but if you, am I still logged into safe? It may be that sometimes you want a reservation, and the way you can ask for one is you can request a reservation. I've never done this before. We ask that you give us at least 60 hours of forewarning for reservations, which is why I can't reserve anything until next Monday. But you can set your start time. Maybe I'll want to start at, let's go 15:00. And your end time, let's say the 14th at, yeah, that'll do fine. Justification for the request. You're basically saying why you need this. It doesn't need to be that hard, right? You don't need to give you don't need to go into the details of any of the science. You can just say, I need this reservation to run a large job, or I've been waiting to queue for so long that I really need to run this job, or whatever. The number of nodes you want, say 2. Then the resource type. You want, I've got loads of access to loads of resource types. Hopefully if I click next, it's not going to ask, oh, fine. This is a demo, please don't action. Then it asks, which account am I using? In this case, it's the TA081. And then it says, OK, here's everything. Are you happy with that? And then you can request it. And if you click request, it'll get sent in as a ticket to the help desk, and you'll have a reservation set up for you, or I would have a reservation set up for me that only I can use. From this time, from this time on the 13th to that time on the 14th. And it would be set up. But if I have, that reservation for that entire duration, I would have 2 nodes that only I could use. They're not part of the queue. No one else can use them. No one else can submit to them. I have 2 nodes all to myself. This sounds great. So why wouldn't you do it? Well, one of the big reasons why you wouldn't do it is cost. For every node hour that you use within a reservation, you will be charged in your budget for 1.5 node hours. So you will go through your budget way more quickly by using reservations in the binomes. The reason for that is, ARCHER2 is meant to be a shared facility. So reserving a large chunk of it just for yourself, just to do your work, doesn't go very much with the spirit and the idea and the justification for why we got the funding originally to have ARCHER2. But we are aware that sometimes you have an absolute need to run something and it's been queuing forever and you just know I don't know, maybe you want to debug something on 10 nodes and you've had enough of just submitting jobs and waiting all day for them to crash after 2 minutes. This is a way around this. This is a way where you can speed that process up. If you do that, when you want to use your reservation, you will need to use the reservation QoS instead of the standard and the short QoSs that I've used so far. And then you'll also need to add an extra command, which is -- reservation with your reservation ID. When you set up your reservation, when the systems team have put your reservation in place, they will send you an email with your reservation ID or your reservation name. And that's the one you need to put into here. Yeah. This says that we have a reservation in place. I don't think we do, so sorry about that. I didn't set one up. I don't think we need one for the jobs that we're running today. We've done SBatch, and now for the next question, for the next exercise, which I guess we should maybe take about 5 minutes for. What are the defaults for various SBatch things? And I guess probably the best way of asking this is, what is the least amount of information you need to put into your SBatch script and for it to still run? And I suggest the easiest way of doing this, if you have copy-pasted this, is if you put a space between the hash and the SBatch, then it's no longer a slurm command, which means that here, none of these are getting done. And if I try to submit this, slurm will be very unhappy with me. See? Job rejected, and the reason is I've not given a partition name. Okay, so I need at least a partition name. Cool. So I think I will, if I give you 5 minutes to play around with this, does that sound like enough time? Or will you all be waiting for me to just go through it? I guess put your hands up if you'd like some time to go through the exercises yourself. Cool. And cool. So there's at least a couple of you, and I guess put your hands up if you would rather I just go through the exercises. Cool. We're split evenly, so I will give it 3 minutes for the people who want to go through the exercises to go through the exercises, and then I'll do it myself. Does that sound okay with everyone? Okay. So I'm just going to go through it rather than look at the answer. The first thing he complained about was the partition. Let's submit the partition. Not happy because there's not a QoS, so let's add a QoS. Not happy because no time specified. So it has submitted with just a partition and a QoS. So there we go. We just need a partition and a QoS apparently. Great. So submit jobs to find out what the default budget or account that the job is charged to and things like that. So what's the exact question? If you do not specify a job option, what are the defaults for Slurm? You need a partition in a QoS. The budget or account that the job is charged to, you can probably find that with SACT, which is the Slurm accounting manager. And if you put -J, it's the later of the jobs, and then the job ID. -J is always asking for the job ID. That tells you a lot of things. So what does it tell you? Tells you the job ID, tells you which bits did what, it tells you the partition it was run in, which account it was charged to, TA81, how many CPUs were allocated to it, and what's the state. This is the short version. You can also get the long version, which tells you everything, including things like the job ID, the name of the job. Oops, here we go. Where am I? So yeah, maximum memory that was used in the job, the node that was used, and the node that used the most memory, average memory used amongst all the nodes. Loads of information that you really don't mind or don't really care about. How long did it take to run? And you'll notice, by the way, that the last one, sorry, I'll just point out that the last one is XT high. So it's how much time we spent in our actual program as opposed to all of the startup costs. The job in total took 11 seconds to run. The part of the job I care about takes 5 seconds. So that's not very efficient, but there's always a 5 to 6 seconds starting time. If you're running a job which takes 5 seconds, that's very inefficient. If you're running one that takes 5 hours, you don't care about the 5 seconds quite as much. The average CPU frequency, how much energy we consumed, that's always a really scary number. When we were implementing when we were testing ARCHER2 before users got onto it, I ran one of the very first full system jobs on ARCHER2, and I was rather scared at the figure I got from the systems team when they told me, "Oh, this is the amount of power you consume." And then you get other information. I'm specifically looking for max time, but that doesn't seem to be in there. But I think, does it tell you actually? The default time is short. No, but there will be a way from the solutions. So here in this case, and actually that's a good point to raise. Here in this case, it just automatically went for TA081. And the reason for this is I've only got one budget. But if you've got sub-budgets, Slurm might not let you run something without defining which budget you're running on. You can get the answers to 3 or 4 by running this. And what does that tell you? That tells you, that tells you what the default numbers are. So actually, because I ran that, I can just do this as well, which will tell me, well, it only ran on a single thread and a single core. So I know that they're 1 and 1. And here it says MPI1, OMP1. So I know that it's going to be default 1, 1. There's another way of, my XT high is good. And then the last one is the most difficult one, which is if you use if you look specifically for time limit, which is one I didn't find actually. Is there a Slurm command for printing out all of the what all the Slurm options are? That's a great question. I've got a cheaty answer for that one. Let me see. There must be a time limit somewhere. If I do just. Nope, that is not done. So yeah, if you use -O specifically time limit, so you're just interested in the time limit, and my job was not that one, it was 2700080. It tells you the default time limit, if you don't say anything, is 1 hour. So cheaty answer. There is a if you Google Slurm environment variables, the first website, which I'll put in chat gives you all of the Slurm environment variables. So things like Slurm CPUs on node tells you how many CPUs Slurm thinks are on a node. CPUs per task tells you the number of OMP threads that you've defined per task. Job ID tells you the job ID, all those sorts of things. But quite often, actually, the one I use most is this one, the CPUs per task. And the reason I do that is, if I look at my submission script, because I do sometimes play around with thread counts. I'll do something like this. We can actually use squiggly brackets. I'll do something like this, which automatically sets my number of OMP threads to whatever I define as the variable here. And that saves me having to update two numbers. I'll put that link in the chat. And I hope that's big enough, by the way. That's probably tiny. But yeah, this is a very helpful link, and it's the one I use to cheat whenever I want to find out Slurm variables. Cool. We've looked at progress with SQ. I'll just check I've not forgotten any, but yeah, there's pending, PD for pending, R for running, CG for cancelled. Cancelling jobs, that's a good one. Let me, oops. And let's just do one node because I don't really mind. That's for 10 minutes. So let's do all I'm going to do is I'm going to do a sleep 60 command, which means that this will take 1 minute and 10 seconds rather than 10 seconds. So my job is running, and let's say that now I realize, oh, I never wanted to run this job anyways. What can I do? Well, you can cancel your job by copying the job ID and doing scancel job ID. And now you'll see that my job is canceling, even though we're 18 seconds into a 71-second job. And if I run this again, it's gone. If you want the more brutal approach, which is the one that I use a lot actually, check that this is running. It's running. And actually, let's submit a few other books. Boom, boom, boom. They're all running now. So I've got 4 jobs running, and I realize, oh, I want to cancel all of those. You can run scancel -u $user, which is your username, and it'll cancel all of your jobs at once. Alternatively, I could have used TA081JS. That would have worked as well. That will cancel all of the jobs by whichever user you define. However, you do not have the permissions to cancel any other user's jobs but your own. So if you accidentally put someone else's name, you're not going to be canceling their jobs accidentally. Don't worry about that. Running parallel applications using srun, well, we've already kind of done that. And I've kind of hinted heavily at how to do that. But the next exercise is talking about underpopulation. So let's have a quick look. When you run srun, it'll take whatever commands you've defined in the top sbatch. So clear. When you run this srun command, unless you change any of them, it'll always assume the defaults that you put there. You can change those defaults, but they have to be to something less than this. So I could do an srun --n tasks per node equals 64, for instance. I'm going to remove all of the Slurm directories that I've built, or Slurm output files that I've made. And if I run that, hopefully, I had to use the watch SQ command because that way I know faster when the job is finished. Or I can tell faster when the job is finished. If I do that, it's still do all 128. Yep, so it completely ignores that. Yep, and there it even says n tasks per node is set to 64, which doesn't match the requested, so we're ignoring it. However, what you can do is you can just set n tasks equals 64, and then you're saying I don't care how many nodes I have or anything. I'm not running more than 64 MPI processes. And hopefully that one will work. It's running. It's probably done. Yeah. And in this case, you'll see at the top it says we're just using 64 MPI processes. If you look, the maximum number of thread is 63 because it's only got 64 processes, and it starts at 0. Cool. But going back to the original exercise, which is this one here, you can define how many tasks per node you're okay with, how many threads per task you're okay with by just playing around with these numbers. And so the next exercise, and you can just define how many nodes you're using by playing with the number of nodes. So the next exercise is, what would you change in your SBatch script to run on 4 nodes with 64 tasks per node, and on 8 nodes with 2 tasks per node and 1 task per socket, and on 4 nodes with 32 tasks per node, ensuring that every an even distribution across all of the 8 NUMA regions. I will again leave you, give you 3 minutes to try this out, and then I'll come back and show the solutions. Please let me know if you have any questions or if there's anything I didn't say clearly enough that you'd like made a bit more clear. Cool. So in the interest of time, I mean, I'll just do this really quickly. So the first one, you want 4 nodes, so nodes equals 4. You want 64 tasks per node. Tasks per node is going to be 64. For the second one, you want 8 nodes. So nodes equals 8. 2 tasks per node. 1 task per socket. I never remember what that one is. Okay, yeah. There we go. It's probably just going to be. Socket. And what do we want? 1 task per socket. We probably want this. Oops. 1 task per socket. So what do we got? We've got 2 tasks per node, 1 task per socket. I'm actually quite interested to see how that one works. And while that's running, the final one, we don't want tasks per sockets. We want 4 nodes, 32 tasks per node, 32, and then the block cyclic is enough to ensure that we're distributing things across NUMA regions. Do note, and I think I said this before, but do note that cyclic being across NUMA regions is actually a bug in Slurm. It should be, the cyclic should be that it's spread across the sockets, so across the actual cores. But this was a bug that we had early on in the ARCHER2 system, and we actually found that spreading across NUMA regions is much more interesting and much more useful than just spreading across cores, across processors. So we've pushed to keep that one in a, because we found that it was really helpful and actually made a lot of tasks really easy, a lot easier. So, but on other systems, if you were to use block cyclic, the cyclic would spread amongst processors within a node rather than spreading across NUMA regions within a node. 42. Cool. 016, 016, 016. And actually here you see the point where it's not going between sockets, it is going between NUMA regions because of that very error that I was talking about. So we've got Slurm set up so that it thinks that every NUMA region is a socket, as opposed to every NUMA region being, every processor is a socket. Cool. Well, I guess that's another way of doing it rather than doing the block cyclic, is you can have the task per socket of 16 and then the cores per CPUs per task, just to ensure that you're sort of like filling up every NUMA region up to what it should be before spreading your job around. So hybrid OpenMP and MPI jobs we've kind of already hinted at already. So the main thing I wanted to do here is really show that XT-High, which I think is an excellent tool, by the way. I know I keep saying this. Yeah, fine. That's I can stay, and let's do 4. Yeah. So here I'm saying that I want 4 OpenMP threads per MPI task. Let's go block block because that's easier to visualize. And because I'm using this variable, this is the same as if I just put 4. It's going to take whatever that number is and put it there. And actually, I will do an echo for the threads. Boom. Just so that we can check. Threads is boom. This will take about 10 seconds to run, but I think we all know what's going to happen at this point. It's a different job from the one that's on display here, but it's going to do very much the same thing. And as you can see, it's saying there are indeed 4 threads, which is what I wanted. Here we go. So here, as you can see, now, because I'm using block block, the first 4 processors are associated to the first MPI rank because they're all separate threads. So you've got 4 threads per MPI rank, which means that all of the cores are, I'm sorry, I should have said cores instead of processors before, but all of the cores are grouped together in groups of size 4, and those 4 each process 1 OpenMP thread. And that's true across the board. So even if I go all the way down to node 2, for instance, out of 3 out of 4, you'll notice that still they're grouped together in groups of 4. These 4 are all node 2, MPI rank 75, OpenMP thread 1, 2, 3, and 4. But that's how you can launch hybrid MPI and OpenMP jobs. So if you've compiled something that can make use of both MPI and OpenMP, you can set your number of MPI tasks, MPI ranks in this case, according to XT-High, by using the n tasks per node, and you can set the number of OpenMP threads by setting the CPUs per task and by setting OMP num threads variable to be equal to CPUs per task. Okay. So we've been talking a lot about the non-uniform memory access regions, or NUMA regions, and I've mentioned that they're basically parts of memory that are really easy to access for subgroups of a processor. So for a subgroup of the cores on a processor. There are 4 per socket, and there's 60-unit core. So if you are looking to run hybrid OpenMP and MPI tasks, your program will be performing much better, much faster if you keep your OpenMP threads within NUMA regions and don't have any MPI tasks who have some OpenMP threads in one NUMA region and others in another NUMA region. That'll all of a sudden increase the communication time. Actually, worse would be in one NUMA region on one processor on a node versus in another NUMA region on another processor on the same node. And worse still would be if there's any OpenMP threads that span from one NUMA region on one processor on one node onto another NUMA region on another processor on another node, because then you need the interconnect. Though you wouldn't be able to do that because OpenMP threads would, you can't have OpenMP threads across multiple nodes. So I'm being, yeah, I will blame it on it being Friday. So given this, when you're running hybrid OpenMP MPI jobs, you want to consider the NUMA region. It's really important. You can get a performance increase by considering the NUMA regions. So what we recommend is you want to do something like keep in mind these magic numbers. If you've got 64 MPI tasks and 2 OpenMP threads per task, that's the equivalent of having 8 MPI tasks per NUMA regions. They're all entirely contained within the NUMA regions, so they'll all go a bit quicker. Likewise, 32 MPI tasks and 4 OpenMP threads per task means that you've got 4 MPI tasks per NUMA region. If you go to 16 MPI tasks per node and 8 OpenMP threads per task, then you've got 2 MPI tasks per NUMA region. And if you go for 8 MPI tasks per node and 16 OpenMP threads per task, then you've got 1 MPI task per NUMA region. And this can have a significant effect. And actually tomorrow afternoon, at the end of the session, one of the optional exercises that you can do is play around with a really quick GROMACS performance, like do some performance testing with GROMACS, where you effectively look for this effect and how much performance drops when you span across NUMA regions is really impressive. So I've already said this, but just to repeat myself, everything that would be output to stream, so the standard output and the standard error from jobs, will by default get written to a file called slurm-yourjobid.out, which I just tend to refer to as the slurm.out files. In this case, I can actually, this is quite useful as well, because if one of your jobs fail and you're ever asked, well, do you know what the job ID was? You can say, well, it's slurm-this, so the job ID must have been 2700156. So yeah, that's quite nice. So if you run into issues, the service desk may ask you to send the job ID. That's what you can do. If you need to change the location of the standard output and error, you can put a output and error names option into your sbash command. I mean, you can do that. Frankly, I don't know. I've never done that. I'm not too. I don't think the benefits. I don't know. I've not seen where the benefits come in for doing this, but it is a possibility. Okay. For the next 15 minutes or so, I'm going to talk about the other methods that you can run jobs, and specifically the other methods that you can run jobs more interactively. So the first one of those is the salloc command. And the way that salloc works is what you do is you run salloc -- you give it all of the same things that you would give to your Slurm job. So account is TA081, partition is standard, QoS is short, nodes is, I don't know, let's go 1. Tasks per node is, let's be boring, and let's do 64. And I put 2 S's. CPUs per task is 2. And let's add time is 0, 10, 0. Press enter. It's not happy with tasks because there's an S missing. So what it does now is it'll say your job is in the queue. You've been allocated resources. We're just waiting for the resources to be configured the way you've asked for. And now your job is ready. You've got this node all to yourself. But note that I'm still on the login node. I'm still on ln01. I run sq. I run sq minus me. You'll see I am running an interactive job on this node. Very quickly, if anyone wants to follow, okay, cool. I will copy that later. So now at this point, I can do things like module load xt high, and then I can run srun xt high, and it will automatically run the xt high command on the salloc node, and then output the output. It doesn't create a Slurm output file, but it does run everything just like I would want. So that's one way of doing interactive jobs. Exit this. And I am going to copy this in case anyone who's following along wanted to try the salc command. That's one way of doing interactive jobs. However, I'm going to run that real quick. I'm very interested to see this actually. Because I'm still on the login node, I suspect that I still have access to the home directory. Do this. Yeah. So it's not quite, I don't know, for me, I appreciate the purpose and the uses of salc, but basically it's almost like you're setting up your own reservation in order to run your jobs within that reservation. You can ask as many nodes for as many nodes as you want and use them up, and you can almost think of it as a reservation you can set up. However, if you're asking for a ton of things, let's go, I don't know, ask for that. This is a ton of nodes. And let's go for 24 hours. I'm asking for loads of nodes for a really long time. Let's go 23 hours, be sensible. What's going to happen? Well, what's going to happen is I will be queuing for a while. And until my job makes it through the queue, I can't do anything anyway. So I'm just going to cancel this because I don't want this job to run for obvious reasons. So back when I was saying I really like SBatch rather than interactive jobs, it's for that reason, that if you're waiting for a long job to run, it can take a while before it runs. Now, the other one that you can do is you can, oh, maybe not that one because that one's terrible. You can srun account partition. You can define any of these, do you? I do want my nodes. One, but this I don't need, I don't think. You can do an srun command from the login node and define, as long as you use this --pty, which is putty, you can, hopefully this works, start an interactive session on a login node. Let's wait for the resources to be configured. And now, instead of, whereas before I was on login node 01, I am now on node ID 3424. I am on a compute node. And if I do sq me, that node is the one that's currently reserved. So I am currently on a node. And if I try to do this, it tells me, well, your home directory doesn't exist because, as I said earlier today, the home file system is not mounted on the compute nodes. So already you've got an interactive environment that's much more realistic to where your jobs will run, which can be really helpful for debugging. You can do all of the things you usually can. So you can load XT-high, and then you can run jobs within it. So srun CPUs, actually tasks per node equals 64, CPUs per task equals 2, x high, and it's not going to do anything. And the reason for that is because you need an extra flag whenever you run anything within these interactive sessions, which is oversubscribed. By default, a node will not be happy about having two jobs associated to it. And in this case, we've got two jobs associated with it. We've got one, which is we're running a shell script on this node, and the second one is the job that I was trying to run. Note also these numbers are not quite the same as they were before. That's okay, we'll overlook that for now. It's more a case of, look, it's running, and it's really not doing the thing that I wanted it to because it's got 256 OMP processes in one MPI thing, so we've only got the thread. But that's okay. It's more to emphasize the fact that if you want to run jobs on a compute node, you can do it this way. Don't ever forget to exit when you finish working in an interactive session, because if you don't, you will be charged for all of the time that you're still in. Cool. So salc interactive jobs. and srun interactive jobs. I should mention both of those. The final one I wanted to say real quick is, let's say module load xthigh. Module list. Yeah, so now I'm back on the login node. This is quite important. I can run my xthigh command. Partition, let's do tasks per node 5 and CPUs per task 25 distribution block cyclic int. Cool, so what am I doing here? All of those flags that I had under the sbatch command, so before in my so before I had, for instance, the number of nodes after an sbatch command. Well, here I've just got it as a dash dash after an srun command. Or I had, for instance, my account. Where's my account? There it is. I defined my account. I defined whether or not I wanted multi-threading. I defined distribution. All of those things I can run directly into an srun command. And if I press enter, at the end I've got my executable. If I press enter, what will happen is Slurm will submit this srun command to the queue, and when the resources are free, it'll immediately run whatever executable I put at the end. And so I can run srun commands from the login nodes, and they'll still queue to run on the computer, which is also quite a neat trick. Yeah. And there you can see it's sort of saying, yeah, this is where I've put all of the various cores. And here, those are the ones which are, I don't know which NUMA region to put them in, so I kind of did it everywhere. Because I went for stupid numbers. I was just wanting to emphasize that you can go for stupid numbers. You might not want to, but you can. I've mentioned about the short queue, and the short queue is a maximum 32, it's maximum 32 nodes for maximum 20 minutes versus a maximum of 1024 nodes for a maximum of 24 hours in the standard queue. But the only difference, provided that you're using a small number of nodes in a small amount of time, is you change your QoS from standard to short. So there's more information and a lot more that I've not covered here in the ARCHER2 documentations, especially on schedulers. We also include a number of test scripts to help you. If you're not sure what you're doing, there will be an example script somewhere that probably does it. And if there isn't, write in and we'll try to write one for you. Where is it? Yeah, there it is. Just want to get it. Yeah, so for instance, here there's a job submission script for any MPI job. Well, here's an example. Do you want one that's sort of like split across NUMA regions? Here's an example. You can do job script arrays. We've got like we've got things for subjobs. So do you want to run multiple full node subjobs? What if you want to run like jobs that take less than a full node and things like that? And we've got all of these example scripts to help you be able to run everything that you want. We also have information about how charging works. We've got information about the various queues is the one that I'm looking for. There we go. Here you have an information about the partitions, what each partition means and what you get in each of them. Here you've got the QoSs. So we've mainly been playing with standard and with short, but it tells you for each of them, what's the maximum nodes you can have per job? Well, it's 1024 for standard, it's 32 for short. There's a QoS called task farm, which lets you have a maximum of 16. Your max wall time is 24 hours for standard, 20 minutes for short. Long has 48, but you can only ask for 64 nodes. You can have this many jobs queued, you can have this many jobs running. It's under this partition, and then there's some notes as well for things like that. So all of this information and a lot more is in the ARCHER2 documentations. So with that, that takes us to the end of today's session. Thank you all for bearing with me. That's next Monday, we will be playing around with debuggers and profilers. But yeah, thank you all for spending today with me. I hope that you found this interesting. I'll stay around a bit to take any questions that you may have. And I will say, I'm aware that what we did today is maybe not the most interesting part of using ARCHER2, but running debuggers and running profilers on ARCHER2 is super interesting. So I suspect you'll have a lot more fun on Monday. For Monday, we will be starting at 10:10 as opposed to 10. If William is feeling better, he'll be giving the course, and if he is not, I will be. So yeah, thank you all for coming. I hope you enjoyed this course, and please do let me know if you have any questions.